So let's deep dive into TrustLogix and its unified Lakehouse policy. I mean, our mission today is really to solve a massive vulnerability in modern data architectures. Just picture locking the heavy deadbolt on your front door.
Right. You feel totally secure,
Exactly, you feel safe. But then you realize you've left like three different back doors completely wide open.
which, totally defeats the entire purpose of the lock. And yet, that is the ultimate illusion of security happening to enterprise data right now.
Yeah, because you put all your energy into securing a primary database like Snowflake. That's your front door. But then you leave platforms like Databricks or, say, Microsoft Fabric completely exposed to the exact same data.
It's wild, yeah.
So today we are exploring how to fix this for you. Because if you're managing modern data ecosystems, well, this is a reality you absolutely have to deal with.
Definitely. And to understand why these backdoors are suddenly such an issue for you, we have to look at what we call the Apache iceberg governance gap.
Okay, but wait, isn't Iceberg supposed to be like the good guy here? I thought it was this open table format that just unifies everything.
Well, yeah, I mean, it is fantastic for storage. Iceberg lets you keep one single physical copy of your data, usually sitting in a central cloud storage location, like an Amazon S3 bucket, for example.
Right, that makes total sense.
But the vulnerability comes from how you actually access that data. Because the storage is completely decoupled from the compute, you end up using multiple compute engines.
Oh, so like Snowflake, Databricks, Dremio, Fabric.
Exactly. They're all being used to read that single unified data set.
Okay, so the data is in one place, but the engines reading it are just totally isolated from each other. They each maintain, what, completely separate rule books?
Yes, which creates a massive blind spot. Let's say your HR team builds a really strict rule in Snowflake to mask employee salaries.
Okay, sounds pretty standard.
Right, and it works flawlessly when someone queries through Snowflake. But if your risk team points Databricks at those exact same iceberg tables, Databricks have absolutely no idea the Snowflake rule even exists.
Wait, seriously, so the salaries are just completely unmasked and totally visible?
And 100% visible.
But hold on, if Snowflake is fully locked down, how does Databricks even see it? Like, why not just copy the rule and type it manually into Databricks, Dremio, and everywhere else?
You could, but manually duplicating rules across an entire enterprise is a total nightmare. Think about the reality of doing that. You have to write the policy in like 5 different SQL dialects.
Oh, wow, right.
Yeah, and while the active typing might just take a few hours, it usually takes a day or two to fully implement, test, and release those rules across all the different teams.
Then during that whole lag, the data is just sitting there exposed.
Exactly. Or you suffer from severe compliance drift. One team updates a masking rule, another forgets, and suddenly your audit completely fails. This is why manual duct tape just fails. Teams either end up maintaining pre-masked, stale copies of data.
Which totally ruins the point of real-time analytics.
Right, or they just get tired of their pipelines constantly breaking and give up and grant open access.
So, okay, if manual duct tape leaves data exposed, and we can't secure the individual compute engines because they just don't talk to each other, I mean, we have to go a layer deeper, right?
We do. We have to secure the data at its physical root.
So how does TrustLogix actually do that?
Well, by using what they call a unified Lakehouse policy. It's essentially a write once, govern everywhere solution.
Oh, nice.
Yeah, instead of anchoring security to those isolated compute engines, it anchors the policy to the universal physical location of the data itself, which is the S3 storage path.
Right, because no matter which engine is querying the data, they all ultimately have to point back to that exact same S3 file location anyway?
Precisely. You write the rule once in TrustLogix, then under the hood, TrustLogix uses APIs to talk directly to the metadata layer of each engine.
Oh.
So it automatically translates your one business rule into the native commands for Snowflake, Databricks, Dremio, or Fabric. And then it pushes the instructions directly into their control planes in like under 5 minutes.
That is incredibly fast. To give you a mental picture of how this works, it is what's called an out-of-band proxyless platform, which means instead of putting a security guard in the hallway to check everyone's ID.
Which creates a massive traffic jam for your queries, by the way.
Exactly. So instead of doing that, TrustLogix just remotely programs the smart locks on the doors.
And it happens entirely in the background. Because the rules execute natively inside each engine, there is absolutely zero query latency added.
Wow, zero latency.
None. The data flows at full speed, and zero data is actually moved or copied.
So what does this all mean for you? I think the core takeaway here is that true flexibility in your data architecture is completely impossible unless your security scales instantly across every single platform you touch.
Oh, absolutely. You simply cannot be chasing policies manually across 5 different engines. It's just not sustainable.
No, it's really not.
Even just dealing with human analysts, the manual workload creates really dangerous gaps in compliance.
Which actually brings up a frankly chilling final thought to take with you today. If managing human access across these fractured engines is already this prone to error, I mean, what happens to your security posture when autonomous AI agents start making thousands of data requests a second?
Right. I mean, if human speed creates a day-long lag in compliance, machine speed will literally blow the doors entirely off their hinges.
Exactly. So if you thought leaving 3 back doors open for humans was a headache, well, just wait until the machines start checking the logs.